Oh, wait,
Oh,
I'm
wait,
sorry.
wait,
I
wait.
did simple math.
Right.
Well, it's what? It's actually going backwards. Over.
Did you get it?
Almost. 1, 3. Wait, should we simplify the bottom or no? Or okay, wait, what's that?
That's one expression. I want you to simplify an expression.
Simplify. Okay, done.
Okay, what's a quick way or the most efficient way to do this? Who'd like to talk us through it? Anybody want to give it a shot? I see.
Divided by 5 up times 5 over x minus 3 plus 1.
So you can think about it as a top divided by the bottom. Oh, sure is. Thank you. Okay, so you could think about it like that. And then what would you do from there?
Make the bottom the same, make the denominator the same, and then just multiply it.
So make it so that it's in the form of a divided by b, like top fraction divided by just a single fraction, right? And then change that into a over b times d over c. Okay, and then that'll work. Okay. Now that is one way to do it. That's not the way I'm looking for. That's why I didn't write down the details, but there's nothing wrong with that way. So keep it. Don't forget how to do that. I'm sure that at least half of you did it that way, but I'm looking for something else, a different way. So if you have an idea, how would you do that? Yeah, that's what I'm looking for. Just clear the denominators. And we're going to have the same common denominator. Well, we still use that common denominator, x minus 2 and x minus plus 3, because we're trying to cancel both of them. And let's see how efficient this works. On the top, we have this times this, which is... Yes. Okay, go right. I'm going to keep it as a factored form, just for fun. On the bottom, we have this times this, which is 5 times. And to keep it like this, just for now. And then this times this is x minus 2. Are we good with that? But you're right. I think it would have been really easy to just distribute. I leave the top factor just in case something cancels. Oh, could I cancel the x plus 3s? But it's a factor.
It's a digit.
It's a factor plus something. Yeah, so it's definitely not a factor in the denominator. But let's see what happens on the bottom, excuse me. So who knows? This is 5x plus x is like 6x, 15 minus 2, 13. Is that right? Is it worth multiplying out the top? Nothing. Yeah, it's fine. It's done.
If you do it for something.
No. Yeah, leaving it like this is fine. Multiplying it out is fine. Leaving it like this is not fine. And I want this to be cleaned up a little bit in the exam to see if something factors out, either a 3 or an x plus 3. It didn't, so we're done with the problem. Who already has something like that? Either that or the multiplied out one. Nice. Okay, if you didn't get it, do something about it. I don't know what's in your brain. Only you know what's in your brain. And I can't help you unless you tell me. So I keep that in mind. Today's quiz is going to be a 20-minute quiz, which means I need the last 30 minutes. And luckily, the lesson is pretty quick today. So I think we might even get started on the quiz a little bit early. What do you think? Should I do this? Make it happen? You ready? Okay, go ahead. Put on your seatbelt. Yes, loosen. It's on paper. I'm sorry. Yeah. Yeah. I think everyone. Does everyone prefer it on paper? Yes, Charlie.
You're saying when you have your judgment.
It was so annoying.
It makes you do like the thing.
Yeah.
You genuinely take on the quizzes on future assignments generally. Would you rather we do that or just put x can't equal?
That's a great question.
You said you're fine. X can't equal.
I want the correct answer. Now, if it says in a particular form, then I want that particular form. But if it doesn't specify, then your job is to get it done quickly and efficiently. In other words, I love x does not equal the two numbers. That's what I would do exactly. You're like, they're gonna make me type all that out. And there are 2 exclusions.
You have to do it like 4 times for the last one.
Oh, really? Is this
The
true?
last one has 5
They made you do that?
So it's like infinity blah 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 blah.
Seriously?
It's just like it's plus, minus, multiply, divide, and division, and then you have a good fraction. Good fraction.
It seems like you were tortured a little bit. That was not intentional. I promise that's not intentional.
It's just us.
I have a question for you, for y'all, as from students' point of view. Every teacher gives their homework a different way, don't they? Kind of like some like listed here, some listed there. Is it difficult to remember how to get the homework assignments? Okay, I'm just. Are you bookmark it? Oh, that's a good idea. Sophie.
It's like kind of a question, but it's about the like what's gonna be on the quiz. So there's a question that says like draw y equals the cube root 4x, and I'm still like kind of confused on how to transform that. So like
Oh no.
do it.
Probably not. I'm sorry. Maybe I'll have a couple minutes in between the lesson and quiz where you can work that out, but it's too late for me to go over it. Sorry. Okay, but anyway, in terms of getting homework, it's not difficult to remember which teacher gives it to you when or from which place.
Evidence are off on Pearson, but you're kind of able to figure it out yourself.
Oh, yeah.
Okay. The one you didn't, the first one that you didn't do, I imagine, is just like the next lesson. Right. So if you did a lesson, you're not going to do that one again, you just do the next one. We're going to skip the first page.
Skip it as in you don't need to know, or like we'll come back.
You don't need to know. You can look over it for enrichment if you want.
Go there.
You could join X if you want. Or any letter you want.
Oh,
Oh, why would you do that? Okay.
That was, yeah.
That was a dad joke, see?
Yeah.
Ask and you shall receive. Thank you. So, everyone's attention, please. Composition of functions. For a second, to look at function as a machine. Have you seen this before?
No.
Someone has seen it before? Okay. Cool. So, nice. He's probably a better artist than I am, but let's say that this is a function machine, which means there's something that's going to go into it.
Something has to come out.
And don't write this down yet. Don't write this down yet. Like maybe a 1 would go into it, then something like happens to that input, and then another number comes out, maybe like a 7 or something like that, and then that gives you an ordered pair, right?
Yes.
Okay, so that's how a function machine works. But we're not going to put in a particular number. We're going to put in an x. Now, if this function is f, then what comes out of f of x? Y, which is f of x. So specifically, this is f of x, right? The function did something to x. So in a composite function, what we're going to do with that output is put it into another function. I'm going to call this function g. So if it goes in there, then the output is
G. Oh wait, G.
G of f of
G of F.
it's g of f of x, isn't it?
Yeah.
Does that make sense that that's the output? That is by definition a composite function. So x goes into one function, then that output goes into another one. Yeah.
But if f of x is technically y, so you're finding the function of y. Just
Yeah, true. Well, it's all about inputs and outputs, though. So we do take that numerical y value and make it the x value of the second function, but it doesn't change its amounts.
7y value, you go to 7x value.
Let's separate it from a graph for now. So it's just a number that goes in and a number that comes out. And graphically, yes, it gets a little confusing if we think about it that way. So it's just a number in and a number out into another function. Sophia?
Can it go through another machine after?
Oh, it could, yes. Absolutely. It'd be like a mega complex. Yes, mega composite, yes. And if like it went through H, then it would be H of G of f of x. I'm a little bit uncomfortable with that notation because it's weird to have parentheses inside parentheses for me. So normally I write it like this. And another way to write this, and this is new notation, is this.
Oh yeah, I saw this.
These all say the exact same thing. When you see that open circle, that means we're talking about what kind of a function? Composite function. And this would be read G composed with f of x. So all those things, yeah,
There's three, it'd be like H circle, G circle, F.
yeah. H composed with G composed with F of X. Yeah. Okay, so you see that, for example, one they've given it. Oh, yes, Lucy. G of X. That's just if a function goes right in there, a number goes right in there, that's G of X.
Oh, sorry, I go G, sorry.
Oh, well, it depends which function's first. So sometimes it's F of G of X, sometimes G of F of X. This one specifically, though, the end, the way it works is, this is the first one that went to, so it's G of F of X. Good question, thank you. Now, this notation is a little bit clunky, so I recommend that the first thing that you do is rewrite it as. Okay, that's it. And I prefer the middle one, so I'm going to rewrite this as F of G of -1. I'm going to give you a moment to figure out exactly what number that equals. And take a moment. Whoa, take a moment. My bar mitzvah was just recently. Thank you. Check with your neighbor once you finish it.
You said nozzle?
Mazel tov.
Oh, thank you.
You didn't.
Appreciate that.
Say how you said it.
No, that's real.
Just mazel tov.
It's not Mazel Walker.
It's the idea that I appreciate.
Oh, wait, I think it's not right. It's negative two. It's negative something.
Did you get it? Check with your neighbor. If your neighbor doesn't know, check people behind you and in front of you.
Right. That's you told me you're multiplying. 3 minus 4. Oh, you're not? But yes, you.
Wait,
you
next time, Jim.
Yeah. Times negative
No,
4.
Times we're doing composites.
Times here. No, it's this, and then you have to plug in the negative. It's not time.
Yeah.
Not doing F of
Okay,
X
okay,
times
okay.
G of X.
Got it?
The rest. Sorry, I'm wrong.
Not yet. Let's make sure we're good. Who'd like to talk us through this one? Make sure we're good.
It's just simple.
That's so.
Everyone want to talk about this one? Have they got what they got?
Not like-
And Charlotte. Okay, so you found G of -1, and what did that equal? Do we agree?
Why would you start with the G? What? Wait.
Yeah, why did you start with G?
Yeah, it
Yeah.
is 9. It is 9.
Why did you start with G?
Gotta shut that.
Yeah,
It's okay. Yeah, how did you know to start with G?
When it was G of F of X,
Huh.
you had the G first. So I knew that the second one is the one you start with.
Nice.
She even
So you recognize the progression here. We're looking at this, we can see that that -1 going right into G, is it? It's telling you what to do right there. Okay, so G of -1 is 9, so I can replace this with a 9 now, and then you get. Do we agree that's 23?
Wait. Oh,
You found
Oh,
that
yeah,
G of
yeah.
-1 is not.
Yeah, so we take that 9.
then you
it's like
replace
you
the
have-
X with
Instead
the
of nine.
Yeah. It's all about following the number line, seeing where it goes. Charlotte, thank you very much. Very nicely done. Did anyone already finish B?
No. I
Take-
wouldn't do it then.
Let's give the other people a chance.
Oh, shoot. This one's tricky.
I will be calling on one lucky individual
With the popsicles?
with a popsicle stick.
Okay. We got 2 times cool stop it. Oh. Oh, got it. That was me.
Check your neighbors. If they're different, one of you is wrong at least.
Okay, wait. Who is it? I think it's Mia. That's what I said. Wait, oh, sorry, they said me. I said Mia.
Okay, ready? Ready or not? Charlotte, I need your help. Yeah, lucky you. Yeah.
I didn't. Do
Do you start with f of 2? Do we agree that that's the appropriate place to start? Nice. Okay, and you found that f of 2 equals 2. Okay, cool. Is what? 6. Do we agree?
Yeah.
I'm not seeing any looks of disgust, so I think that's correct. Thank you, Charlotte. Very nice. You proved that you still know it. You didn't forget. Mazel tov. You're welcome. Okay, so this one's a little bit different, isn't it? The C?
Oh, yeah. Oh, I know.
That's a little different, but it's okay. We can do it. I'm going to rewrite it first of all. This is just f of g of x. I'm going to give you a moment to maybe think about what to do here and discuss, and then work it out. See if you can figure it out.
I think we put wherever we do X and F is X for the G. Wait,
Oh, wait, almost.
Isn't that just the same? G of X is,
oh, I know.
like, G of X is already up. Oh, and then you plug in, it's plug in 4x and 3x.
Okay, I think I got X plus. You guys got G then. Okay.
I have a feeling that some of you are getting it already.
Yeah. This is very.
How do you like it? Because I'm going to ask for some help from anyone whose name does not rhyme with Schmarlet. Not naming any names.
I think it's
Birdie.
about something that
You get-
I think he's asking for someone. No, he's not, and you picked the possible stick. I heard it.
Okay, so who'd like to tell us how to do C? How'd they do it? Walker, yes.
I did it, G of X
Mhm.
equals, it already tells us x squared minus 2x plus 6.
Okay, so we can kind of replace this, can't we? If we wanted to. Okay.
Then I plugged in that to 3x minus 4.
Does that make sense, folks?
Yeah.
So it's going to be 3.
3x squared minus 6x. plus 4.
Oh,
Well, I'm not going to distribute yet because you know me. You know me. So this times that. And then what after this?
3x squared.
I need to finish that line.
Oh, minus 4.
Are we good with that line? And I really love how you're distributing first. I'm just enough for instructional purposes. So ultimately we have 3x squared minus 6x
Plus.
plus 14. Yeah? Charlotte, do you approve of this? Okay, Sophia, do you have a question?
how is it like logical that we're replacing X with something that has a bunch of X's in it?
Right? It's weird. A whole function's going into another function. I know.
Yeah, but what if it isn't one?
Well, what if X is 2? Yeah. Yeah, if we go back, and thank you for asking this. If we go back and start and try the first problem again, what would happen if we just plug in a -1 into this?
Oh, it's like a thing. It's an answer.
3 plus 6, which is 9 plus 14. 9 plus 14 is 23. So if I gave you a bunch of questions, rather than do them one at a time, you could just find the composite and plug it into that.
So that one.
So if I gave you a bunch of questions, rather than like first find G of -1, plug it in that, find G of 2, plug it in that. But instead of doing both in 2 parts, just find the composite, plug these numbers
Of, like,
into the
the
composite
X.
just once. But the choice is yours. You could plug it into, you could think about this as we did for A as well.
So with that, the composite here would be 3x squared minus 6x plus 14.
Yes.
And then you can plug in the -1, 2, or the 10, like one at a time.
Yeah, exactly. Yeah, well summarized. Who finished D already? Oh, I didn't ask you to. Okay, but it looks like about a third of you already finished D. So let's give other people a chance to catch up to you. Superstars. And we'll be calling on one lucky individual.
She's right, it is 30.
I'm not gonna let it rhyme with schmucker, or maybe I will.
Not bad.
We did it wrong.
Pretty finished. Check with your neighbors when you're done or stuck. At this point, you should probably check in. Make sure it's going well. You two just relax and enjoy while we proceed with our attempts. Are you ready?
Oh, no.
Are ready or not? I want to see what you got. Mia, can you help us out with this, please?
So it's e of f of x, so, f of x is just 3x minus 4, and then e plug it in for x.
So in this case, this is going into these x's. Okay.
So it's x minus 4 squared minus, 2 times 3x minus 4 is 6.
Are we good with this step
Yeah.
so far? Can we stop here? Probably not. You always want to clean things up, so help us out.
X squared minus
Minus one.
30x.
Can you give me the next line that you got? I imagine.
X squared minus 24x plus 16 minus 6x.
Plus, and plus 8 plus 16 plus 6. Okay, and then finally you got 9x squared plus 30. Do we agree?
I'll have to factor out the 34.
Oh, good question.
You factor out at 30.
But then it becomes.
You can do a 3.
We can factor out a 30 of the last two terms. Should we do that? Oh, a 3. You said a 3, factor out a 3. Should we factor out a 3?
Yeah, I mean,
Well, looking back, I mean, I guess I could change the 6 to a 2 times 3. Is that better? Well, isn't it better to always factor stuff? No, no. Unless there's a reason to, you don't have to factor it. So yes, you could factor it, but if there's no reason,
it
don't.
like simpler though, because you don't really want to do 30 times 6.
Like if you're plugging in numbers. Oh, that's interesting. So yeah, if you have to get some values, that'd be a nice idea.
10
Where's the 24x coming from, Eli?
Yeah. Oh yeah, Mia, where did you get that 24x? This one right here.
Like 3x minus 4, 3x minus 4. So
Wait.
it's negative 12x minus 12.
Oh, so you didn't use the 2ab?
I did.
You did, okay. Yeah, I mean, you're right, that comes from the negative 12x minus 12x. I need you all to very, very comfortable with that relationship. How many people are super comfortable with that already? That's great. Well, I think that was 100%. Then I know Mia's already, she raised her hand, but and you got it, so I know you're comfortable. Okay, let's move on. Okay, excluding values from the domain of a composite. Don't plug in numbers. That will break the composite. Which seems kind of obvious for a domain, doesn't it? Just any number but numbers that will break it. Okay, so looking at example 2, we see that there are kind of two numbers that come to mind immediately, aren't there? The numbers are 1 and 0. But not too quick. It's not that easy, of course. So I know, oh. Let's think about this as a machine. I'm going to rewrite this again just because it's more intuitive for me. You don't have to if you don't want to. Okay, so according to this, the story goes is that X goes into X goes into G, and then that output goes into F. So I'm going to make my little machine here. My first machine is going to be G. I'll put G in the corner, and I'm going to explicitly say that it's 3 of X. So into this first machine is anything. Anything but
0.
0. Thank you for helping us in. So I'm just going to say X is not equal to 0. Okay, then out of that is going to come some number. Could be like a bunch of different numbers, and then that's going to go into F, which is 2 over X minus 1. Now my question to you is, could we put a 1 into this first machine? Is that okay?
No, because like later.
So we're gonna 1.
Never mind. Yeah. No, because
It's okay to put a 3 in here, isn't it?
X equals 1.
So see if you can find the number that you cannot, that will break this machine.
A 3, but like, but a 3, obviously.
But is this true?
That's 0.
Aside from that, I don't understand. Is X still the same thing as X?
Yeah, X is the number that goes.
1. In 3 over 1, and then you put a 1 into
No.
1 minus 1. What? The Zoom is getting along.
Yeah.
Are you gonna put it up on YouTube? You're gonna watch it later.
This is going on YouTube for sure.
You put the 1 in, and then you get 3, then X equals 3, and then.
Now, we're not putting a direct number directly into here, but we know that if we were putting a number directly into it, it couldn't be 1. So what makes 1 coming out of this?
3.
3. And that's why X can't equal 3.
1.
X can be 1.
I thought we established that. No, but then it makes
No.
3.
I'm not putting 1 in here.
Why?
1, it's a composite. 1 goes in here. That output goes in here.
Okay. 0. Okay.
And then it is happiness. Or this is, I guess it's specifically F of G of X. So it said the domain of F composed with G of X, and say X is not equal to 0 or 3. Should I do that in interval notation?
You
Would you
can't.
like to type that out in interval notation?
Practice. Let's practice.
No, me neither. Okay. So there's steps to do this. Oh, actually, we didn't find F composed with G of X. Can you please find F composed with G of X? Find one expression. Use your algebra skills.
Oh, this is all you have to do.
I see. Mhm.
Oh no. What's the G and then that? Yes.
2X.
Me too. Good job.
You
Oh, and then.
can see
That
X
thing-
can equal 3.
I was.
It literally.
Did we get this?
Oh, yeah.
Yeah.
Well,
Can you simplify this? How do you simplify it?
2x over 3.
Multiply it top and bottom by X. Okay, so we get 2X over 3 minus X. So whereas before it may not have been obvious what can't be X, perhaps here it's a little bit more obvious that X cannot equal 3. This is a composite. So that one fell us. Because we kind of had to do a little bit too much brain work thinking to think about that 3 as it was. So first you think about what the domain is of in the first function, and then just look at the composite and see if there are any other restrictions on that value. So the steps. Find domain of, should I say inside function? Does that make sense if I say inside function? Or first function, however you want to think about it. Just make sure that it makes sense of, I'll say inside function. Yeah, this is the inside function. I'll put that here, inside. Sure. Then find domain of the composite. Yeah. Okay.
You say y'all?
I said yeah.
Y'all?
Yeah, y'all. Find that.
What blogger? What added?
Something.
What? So why don't they just give it to us as like F and the brackets and stuff?
Yeah, I don't know. Maybe they'll have an application in future math classes. It's good to know.
Burden is two.
I don't know.
Oh.
Mhm.
So it's nine, it's nine. 25.
What did you guys get? Is there a chance that this has an install? Yeah.
Oh, very astute of you. Maybe.
You mean an inequality?
Exactly. What does that mean? Oh, it's square root.
Oh
Oh,
yeah, you smart.
It's 2 minus x. This is just 4 minus 2.
Yeah.
2 minus, oh, yeah.
Yeah, okay.
Liv,
Serious.
sounds like it. You're picking up on and putting down.
Okay,
4
okay.
minus x.
Wait, who said that? Liz?
I need some help.
Avery.
help.
Jaden come? I'm sure he could. Unfortunately, Destiny is called Birdie.
Oh.
Next time,
I mean-
hopefully. Okay. Okay. Okay.
Root 2 minus x squared.
Okay. Last one. Cool. That seems pretty difficult. No. Oh, okay. Sorry.
And then you get 2 minus x plus 1, and so your answer is 3 plus. And then you, good job.
And then what? Did you put a box around it or something?
Yes.
Yep. And then
Are we good so far? Do you want to talk? If it asks for standard form, that would be nice, but it's not necessary. Thank you. That's perfectly fine. Bertie, do you want to talk about domain, or you want me to ask someone else to discuss it? Okay. Does someone want to talk about domain here?
All good.
Sophia?
I don't like know the right answer, but
Oh, okay, I like that.
I'll just say like my thoughts.
Okay.
So we look at the original and we know that it can't be a negative number in the square root.
Okay.
So it's definitely not negative infinity to infinity, which is
Okay.
what I originally put. And then
Okay, so
I
watch
was-
out.
yeah,
Okay.
and I did bracket 2, comma infinity parentheses because it can be 2.
Bracket 2, comma infinity. So like x could be 3. Really?
No, wait, it's opposite. It's opposite. Wait, I think it's.
So it's infinity, comma 2.
It's 2.
No.
That's that
Okay,
opposite?
That's where I'm at now. I'm seeing that I did the opposite. Like, okay, so it can't be any negative values. So it has to be 2 equal to or greater, no, or less than 2.
So x is less than 2, but it could be equal to 2, you're saying?
Yeah.
Do we agree with this? X has to be less than or equal to 2. Very nice. Could someone tell me how to get that algebraically? Yes, Mia.
3 minus x is greater than.
Does that make sense that this is exactly what Sophia was saying?
Yeah.
Just using algebra, and then algebra will save us. We don't have to worry about anything else as long as we do it correctly. Let's work this out. 2 goes over the other side. Negative x is greater than or equal to negative 2. When I divide by negative 1, we have to remember to flip the sign. Exactly what you have.
So it wasn't an equality. Let me try.
Yes.
You can't have 0 in the root.
We took it.
Why not? 2 minus 0 is not it. In the root, you can have 0. Square root of 0, we know what it is. If it's a denominator, you can't have 0 in denominator.
It's the square root of 0.
I mean,
0. But if it's like this, then there's a problem. And if it's the bottom of a fraction. So the domain of this composite.
what did you do it, Brisa? It's 2, wait, negative infinity, comma 2, bracket. That's why I got it.
Well, the steps were to consider the domain of the inside function, which is exactly what Sophia helped us with. And then we have to consider the domain of this one. It can't be three.
No, that's.
Well, it has to be less than 3 or 2.
So you have to do like the limit.
I think there's no further restriction here.
Yeah.
So we don't have to do anything else. Always the first one, and then look to see the last one if there's anything else that we didn't catch.
Yeah.
So yeah, here you could do it like this. You could do negative infinity to 2. If you want to do a formal set notation, you can. X such that X is less than or equal to 2 if you really want, if you're one of those crazy people. But you could just leave it like that first one. That's what I would do. Sophie, you're with me there? Thank you. Okay. Yeah. Right. Who would do that, right? Yeah. Okay, last thing. Decomposing functions. What that's saying is that we're going to give you a composite function, and it's up to you to break it up into 2 different functions. So here is a composite function. It's already given to you as 1. What I want you to do is find f of x and g of x such that f composed with g of x is equal to h of x. So find this. I need to give you a command here. Find f of x and g of x such that f composed with g of x is equal to h of x. Maybe some of you have no idea what's going on. You can check with your neighbor.
What are you guys doing?
Okay. Which one should we do first? F of x or g of x? Liv, do you want to tell us what you did? Would someone like to tell us? Wait, you're right, because it's so right that g of x needs to come first. So what is g of x? Yes, we see. Does that make sense? X squared plus 1 is a great choice. And then what does that go into? Exactly. So if this is the inside function, what's inside that radical?
Why would it just so?
X squared plus 1 goes inside of this, and that results in your ridges. Yes, Charlotte? There's a lot of different possibilities. This is the most natural possibility. Yes.
But wouldn't like f or g of x being x also?
Yes, it would be,
Why would it not?
because that one is not acceptable. I'll tell you what is acceptable.
You're gonna keep root 3. I mean.
And we're trying to get this because when this goes into this function, we'll have the cube root of x squared plus 1.
No.
So, and then we're done with that. Another option,
Why is mine not acceptable? Why is it cute?
I'll tell you. I'm so sorry. I need to get through this. This is another acceptable case that g of x is just x squared. If it x is
Yeah.
x plus 1. Do you see that if this goes into here,
Yeah.
the result is h of x? Same thing here, goes into here.
Oh. I
So-
get why mine's not acceptable.
Right, so it is true that if g of x is equal to x, this will always work. It would still be squared, except f of x would just have to be cube root of
The thing.
x squared plus 1. Right, so one of them is a function, so it hasn't changed much.
Wait, so
This works.
Yeah, no, no.
This one is not acceptable. And this is that we've used an identity function. It's this identity function, number equals itself. Okay, I hope you enjoyed composite functions. I think they're great. Make sure to do your homework. Not Sunday night, but maybe tonight before you forget about it. I need some help passing out these quizzes. Who's a good paper passer out? I do it. Thank you, Sophia. We'll all start together, as always.
Your own side. Good luck, guys. Yeah. Good luck, guys. Oh, good luck, guys. Have you had any more? Good luck, guys.
Yes, at least one in each class. Right? I don't get it. All ready to start? We'll start together. We'll start together. Ready. Is it important to put the block? Is it important to put your name? Yeah, at least last initial too. Just help me like find it quickly in case someone else shares your name. I'm gonna count you off to start with this, and you could, if you haven't finished the honor code, you could do it after. 5, 6, 5, 6. Have fun. Thank you.